Hello, ladies and gentlemen. We are going to have a goal today of using similarity, specifically similar triangles, in order to find missing sides and missing measurements. And this is actually the last section in chapter 2, and it really is where everything we've been learning in chapter 2 comes together. And this is one of those things that you can genuinely use out there in the real world. It really helps us when we're doing anything from construction to building and decorating in your home and all of those kinds of things. So let's get going on a skill that we're going to need in order to be able to find missing sides. And you noticed in our last class that similar triangles often use ratios and proportions. And so we need to be able to solve a proportion. So in this case, we have a proportion which has an equal sign in between the two fractions. So we know that 8 times the quantity, r minus 9, is the exact same value as 5 times the quantity, r plus 5. So let's take a moment and write that as an equation. So now that we have this written as an equation, it becomes a distributive property type equation to solve. And I'd like you to take a moment and solve this equation in your notebook, and we'll go over it in a moment. So here is the work that I expect you to be able to show. We use the distributive property in order to get step 2 right here, and then we have to use inverse operations. So because this is a subtraction here, minusing 72, the opposite of that is adding 72 to both sides to get rid of the 72. And now down here on this next step, after we simplify, we are subtracting 5r from both sides because this is a plus 5r. We have to do the opposite. It's called inverse operations. Now, intentionally, many of the ratio problems that I give you have funky fraction answers so that you can't mental math. That's very intentional. So don't be alarmed if you do have funky fractions, and we're just going to leave it as 97/3. That's it. Done and done. For our second problem here, we are looking at similar figures. Okay, these are not triangles, but it's going to help us identify new and old. Okay, so we did look at this exact figure in our class last week, and we said that 18/6 equals 3, and also 24/8 also equals 3. So we know the scale factor between these two figures is 3. But what if we wanted to make another letter C that was only 2 units tall? What would the base of that little fella have to be? Well, we're going to use our new over old strategy. So here are the steps to using the new over old strategy for finding missing sides of figures. I would like you to take a moment and copy this in your notebook, then we'll go through it step by step. Step 1 is to make sure that the figures are drawn separately. Now, that implies that sometimes the figures are drawn together. In this case, the figures are drawn separately. So that is basically a step we can say, check, done. They have already been drawn separately. Okay? Step 2 is to identify corresponding sides. And I'm going to use a highlighter in order to show that to make it easier for us to identify. Okay, so I have chosen the base of my new to be purple and the base of my old to be purple as well. Now I use the height of my new to be blue and the height of my old to be blue as well. Now you might be wondering, what happened to this guy over here? Well, I'm just opting to use only one. You only need one figure to be the old figure. So I am not even using this guy. And that is okay, so long as we know that the two figures we are using are similar to each other. Okay, so here's what we're going to do. We're going to take the new purple, which is a question mark, but we're going to use the letter X to represent the unknown, over the old, which is 18 on the old. Alrighty, there we go. And we're going to use the new blue here and the old blue here, 24. We always put new over old, and that will ensure that our proportion matches. Okay, so that is a check, check. And we have a proportion started here, and we are going to solve it and see what that height or base is of our new little tiny letter C. So as we reduce 36/24 to 3/2, we would actually reduce that into a decimal of 1.5 units. We do not, oh, we do have centimeters up here. So we would actually use centimeters as our units, because if you have actual distance, a decimal is probably a better answer than a fraction. And you want to make sure you label with either the word units if you're not given any units, or the units that have been provided, in this case, centimeters. All right, for our next problem, here is where things get interesting. And this first step becomes so very important. Make sure figures are drawn separately. We do actually have two triangles in here, and it is sometimes difficult to visualize. So it is very important that you take some time to incorporate and redraw the triangles and label them carefully separately. So I'm going to start that here. First off, I have my little tiny purple triangle there, okay? And the side length from A to B prime is 4, so I can label this side 4. The side length from A to C prime is X, so I can label that side length X. From B prime to C prime, I don't have any information at all about how long this side is, so I'm just going to leave it blank, okay? And that is how we get this started. We just pick out the information that we do have and incorporate it into our new drawing. So now we have this much larger triangle, and let's go ahead and try and get that little fella drawn, okay? From B to C, we have no measurement, okay? So from B to C right here, we're gonna leave empty, all righty? From A to B, that's this right here, that actually is 4 here and 6 here. So the total of this side length from A to B is 10. You have to do some investigating, okay? Now from A to C prime right here is X, but from C prime to C is 9. And I can't actually combine like terms here. So the only way I can label this is as X plus 9. That's it. Okay, that's all I can do for line segment AC. So we have drawn separately and labeled our triangles in our figure. And remember, the goal here is to find the value of X. So we're looking for what is that number right there, okay? And we're going to use similar triangles to do this. These are similar, alrighty, because we know that this angle is congruent to this angle, and they are actually telling us that they are similar. So we can assume that all of these angles are congruent here, and here, and here, and here. Okay, those are similar. So now let's identify corresponding sides. Okay, based on our angles and the location of our triangles, we should be able to do that. So let's get that highlighted. All right, so things are getting a little crazy here with all the different colors. Hopefully you can tell we have a yellow A to C prime, we have a yellow A to C, and so on and so forth. So what we want to do is we want to do a new over old strategy. Okay, so I'm going to call this my new guy, and I'm going to call this my old guy. In the absence of them telling you which is which, you can choose. It doesn't matter. You can pick which one's new and which one's old. Just be consistent, okay? So my new yellow, I'm going to put over my old yellow. All right, so I'm going to put X plus 9, that's my new yellow, over my old yellow, which is X. Okay, now the blue guy down here doesn't have a measurement on either of these, so I don't even care. I'm not going to use those. I'm going to use my orange, okay? So my orange new is 10, and my orange old is 4. Whew. All righty. So now we have a proportion set up. I'm going to give you a second to solve that proportion like we did in our very first problem. Go. Okay, last problem here. We have another pair of nested triangles, and I am telling you these are similar triangles, and we are being asked to find X. Now we notice that there is a Y here that is unknown. We're not going to worry about Y for now. We're just going to worry about finding X. So step 1, make sure these figures are drawn separately. Would you take a moment to draw and label these triangles in your notebook? Okay, so our larger triangle here is the orange triangle. And that's my little guy on the left here. And from Q to P, we have a distance of 12. So let's label that. From Q to S, on the right side, we have 9, but we also have 3. So we would have to add those together. 9 plus 3 gives us 12 there as well. On the bottom, this is very interesting. We have 15 and also X. Now, those are not like terms. So we can't just mooch them together. We have to add them together. So X plus 15 is our base of our first triangle. Okay, how about our second triangle? All right, he's the little guy here in blue. From R to S, we're being told is 3 units. So let's label him 3 here. Okay, from R to T is Y units. Now I'm going to put the Y there, even though we're not going to be solving for Y in this particular problem. And the base from here to here, we have labeled as X as well. Okay, so now that we have made sure that we have drawn our figures separately, let's go on to step 2. Identify corresponding sides. And I'm going to use a highlighter. Please try this in your notebook. Okay, so these delightful little triangles are oriented just so that the green is on the right, the yellow is on the bottom, and the left has this pinkish red color. They're not always that way, so you do have to be careful sometimes in order to match up our corresponding sides. But now that we've been able to do that, we're going to go on to step 3, and that is to write and solve a proportion using new over old. Now, which one do we want to make new? I just tend to make the one on the right new and the one on the left old. It just keeps me consistent when I'm setting up my proportion. Whatever you want to do though, okay? So I'm looking for X. So I know that yellow has to be incorporated in my proportion, okay? I can't ignore those X's in order to find X. So I'm going to put new from my yellow here, which is X, over old, which is my old yellow here, X plus 15. Okay, and then I'm going to come over here, and the only one that's actually got a number for me is the green. So I'm going to use green new, 3, over green old, 12. Okay, would you take a moment, solve that in your notebook?